What if I told you there are planets drifting alone in the vast darkness, galaxies that warp light like magic tricks, and moons that have their own moons, or that there could be entire planets made of diamonds and stars so powerful they explode with the force of 100 supernovas? In today's video, we're exploring the most mind-blowing, unexplained phenomena in space. Get ready to question everything, because what you're about to learn might just change the way you see the universe forever. 10. Moons. A hypothetical dance of moons around moons. Imagine a moon orbiting a planet. Pretty standard, right? But now, picture another, smaller moon orbiting that first moon. This is the concept of a moon-moon, or a submoon. While no such objects have been definitively observed, the concept is scientifically possible under certain conditions. For a moon-moon to exist, it would need to orbit far enough from its host moon to avoid being pulled apart by the planet's gravity, but close enough to remain within the moon's gravitational influence. One of the most intriguing candidates for a former moon-moon is Saturn's moon Iapetus. It has a giant equatorial ridge that might have formed as a result of a submoon crashing into it, or being destroyed due to tidal forces. Additionally, Saturn's moon Rhea has a faint ring system. If proven, it would suggest that Rhea could have once supported a moon-moon. The idea of moons having their own moons sparks our imagination about complex orbital systems and the intricate gravitational ballet that keeps celestial bodies in place. 9. Rogue planets. Lone wanderers of the cosmos. Imagine a planet drifting alone through the vast emptiness of space, far from any star to call home. These are rogue planets, which have been ejected from their planetary systems, either due to gravitational interactions with other planets or even catastrophic events like stellar collisions. They don't orbit a star like Earth does around the Sun, meaning they don't receive any light or warmth from a central source. Rogue planets can be massive, like Jupiter, or even smaller Earth-sized worlds. One example is the potential rogue planet SIMP J01366565 plus 093347, which is about 12.7 times the mass of Jupiter. But what's most mind-boggling is that some scientists speculate that these planets could still harbor life. How? Despite their cold and dark existence, internal geothermal activity could create pockets of warmth, perhaps beneath thick ice layers, allowing liquid water and even life to persist. Could rogue planets be the ultimate hideouts for alien life? 8. Antimatter fountain. A galactic mystery at the heart of the Milky Way. At the center of our galaxy lies a cosmic enigma, a mysterious source of antimatter spewing positrons into the surrounding space. This antimatter fountain has puzzled astronomers for decades. Normally, when matter and antimatter collide, they annihilate each other, releasing massive amounts of energy in the process. So, why is there such a fountain of antimatter at the Milky Way's core, and where does it come from? One theory suggests that the supermassive black hole at the center of our galaxy is responsible, creating these positrons during high-energy events. Another intriguing hypothesis involves dark matter, a mysterious substance that makes up about 85% of the universe's mass, but has never been directly observed. Some scientists believe that the annihilation of dark matter particles could be producing the antimatter fountain. It's a tantalizing possibility that touches on two of the greatest mysteries in physics: dark matter and antimatter. 7. Double quasar. The cosmic mirage that bent light and minds. Back in 1979, astronomers were amazed when they discovered what appeared to be two quasars, extremely bright and distant objects powered by supermassive black holes, right next to each other in the night sky. The odds of finding two quasars so close together seemed astronomical, but what was even stranger was that these two quasars looked suspiciously identical. It was soon revealed that they weren't two objects at all, but rather one quasar whose light had been bent and split by the gravity of an intervening galaxy, creating two images of the same quasar, a phenomenon known as gravitational lensing. This discovery was groundbreaking because it confirmed a prediction of Einstein's theory of general relativity, that massive objects like galaxies can warp the fabric of space-time, bending light and creating optical illusions. The light from one image of the quasar takes a slightly longer path than the other, meaning that changes in the quasar appear in the second image about a year later. It's like looking into a time machine, seeing the same cosmic event twice, but separated by time. 6. Omega Centauri, the galactic cannibal's leftover core. Omega Centauri is not your typical globular cluster. It's a densely packed collection of millions of stars, all bound together by gravity. But what makes Omega Centauri so special is that it's thought to be the leftover core of a dwarf galaxy that was devoured by the Milky Way billions of years ago. Unlike other globular clusters, which tend to contain stars of the same age and composition, Omega Centauri has stars of different ages and metallicities, suggesting a more complex history. This cosmic cannibalism is a reminder that galaxies are dynamic, ever-changing entities. The Milky Way has consumed numerous smaller galaxies throughout its history, and the process continues today. In about 4.5 billion years, the Milky Way itself will merge with the Andromeda Galaxy, creating a new, larger galaxy. Omega Centauri offers a glimpse into this violent yet fascinating process of galactic evolution. 5. Hoag's Object, the perfectly round mystery. Discovered by astronomer Arthur Hoag in 1950, Hoag's Object is one of the most visually stunning and puzzling galaxies in the universe. It consists of a nearly perfect ring of bright blue stars surrounding a yellow core, with an empty space in between. Galaxies like this are incredibly rare. Ring galaxies make up less than 0.1% of all observed galaxies, and their formation is still not fully understood. One possibility is that Hoag's Object formed after a smaller galaxy passed through the center of a larger one, triggering waves of star formation that created the ring structure. But the symmetry of the ring and the near-perfect emptiness between it and the core make Hoag's Object a cosmic enigma. To add to the mystery, another rare ring galaxy can be seen through the gap in Hoag's Object, making the alignment of these two unusual galaxies a rare cosmic coincidence. 4. SN 2006 Gi Hypernova. A stellar explosion beyond imagination. Supernovas are some of the most powerful explosions in the universe, but SN 2006 Gi was no ordinary supernova. It was a hypernova, an explosion so intense that it was about 100 times more powerful than typical supernovas. When it exploded in 2006, SN 2006 Gi briefly shone brighter than the entire galaxy it resides in, outshining billions of stars. The star that caused this hypernova was likely a supermassive star, tens of times more massive than our Sun. Scientists believe that matter-antimatter reactions at the core of the star played a role in the explosion, creating a runaway chain reaction that tore the star apart. What's even more fascinating is that we have a similar supermassive star right in our galactic backyard, Eta Carinae. This star is on the verge of exploding and could produce a similar hypernova. When it does, the explosion will be visible even during the day, lighting up our sky with an awe-inspiring display. 3. Thorne-Zitko Objects, the mysterious stars that shouldn't exist. Thorne-Zitko objects are one of the most exotic theoretical objects in astrophysics, a star within a star. These bizarre objects are thought to form when a neutron star, the dense remnant of a supernova explosion, is swallowed by a red giant star. The two stars merge, creating a unique system where the neutron star resides at the core of the red giant. Although none have been definitively confirmed, TCOs could help explain some peculiar stars that don't fit into the typical categories of stellar evolution. These stars would exhibit unusual chemical signatures, like an overabundance of certain elements due to the extreme conditions at their cores. The discovery of a TCO would not only confirm a fascinating new type of stellar object, but also provide insights into the final stages of stellar evolution. 2. Stephan's Quintet, the Galactic Ballet, and a Quasar Puzzle. Stephan's Quintet is a famous grouping of 5 galaxies that appear to be in the midst of a cosmic dance, their gravitational forces pulling and distorting each other. But upon closer examination, astronomers discovered that one of the galaxies is actually much closer to Earth than the others. This optical illusion saved the credibility of redshift measurements, which astronomers use to determine distances in the universe. Yet, the puzzle deepens. One of the galaxies in the more distant group appears to be interacting with a nearby quasar, a supermassive black hole that is devouring matter and emitting immense amounts of energy. This raises questions about how redshift and quasars work, challenging our understanding of these cosmic phenomena. Stephan's Quintet, with its mix of galaxy interactions and quasar mysteries, remains one of the most intriguing astronomical puzzles. 1. Diamond planets, alien worlds of precious gems. In some parts of the universe, planets made of diamonds might be a reality. Carbon-rich planets, like the exoplanet 55 Cancri E, are thought to contain large amounts of graphite and diamond, potentially giving them surfaces covered in precious gems. These planets form in star systems where carbon is more abundant than oxygen, leading to the formation of carbon-based minerals instead of the silicate-based rocks we find on Earth. One of the most astounding discoveries was a diamond planet orbiting the pulsar PSR-J 1719-1438. This planet is likely the remnant of a white dwarf star that has been almost entirely consumed by the pulsar's gravity, leaving behind a dense core made mostly of crystalline carbon, essentially a giant diamond floating in space. Such discoveries stretch our imaginations and challenge our understanding of planetary formation, showing us that the universe is far stranger than we ever thought possible.